Okay, so this is part two of momentum and impulse for those of you who are interested in going through some questions and problems together. And this is essentially a summary of everything that we recapped last in the last video. And so to quickly go over the five main formulas that you need to know for forces and mechanics are that F equals ma. Force is mass times acceleration. Momentum is defined as the mass times velocity. It's essentially how much striking power an object has. Um, and we also know through Newton's laws that the conservation of momentum means that m1v1, which is before, let's say, a collision or let's say a change in the system, is equal to the momentum afterwards, which is m2v2. Then we can rearrange F equals ma, where a equals the change in velocity over time, to give us this new equation, which is nothing but a rearrangement, and it's just delta mv over t, which is the rate of change in momentum. Then we can multiply both sides by time, so we get the impulse of an object, which is just how much time, which is just how much the momentum has changed, and it's the product of the force times the amount of time it was applied. And so we have all of that information with us now. All right. And with that said, let's start doing some problems. I'll just clear the space. And now what we're gonna do is we're gonna hop right into it. So let's see. Determine the momentum of an electron, which is this mass, moving at this velocity, as if it were in a Bohr orbit in the H atom. So let's just forget about this in a piece of information because that's not very important. We can assume that anyway. So we know that P equals mv. And also, by the way, if you're watching along, just try and do these questions as well as we're going through them. You know, pause the video or something and then resume it to see if you got it right or not. So P equals mv. We know that m equals 9.1 times 10 to the minus 31, and v equals 2.18 times 10 to the power 6. Okay, so our p is going to equal 9.1 times 2.18 times 10 to the power minus 31 times 10 to the power 6. Okay, I'm going to start writing with a text box here. I think that's probably a bit neater. So you can basically just take out your calculator for this one. Now the thing with physics is your answer doesn't have to be completely exact. So you know your teachers will accept a little bit of rounding here and there. But generally, of course, you want to have an accurate answer. So I'll just multiply this on my calculator, and our answer is 19.8. So pretty close to my estimate over there of 20 times, what do we have? So when we have standard form, right, and when we have powers of 10, if we have 10 to the power minus 31 and 10 to the 6, we just add the two, so it becomes minus 31 plus 6, and so the answer is just 10 to the power 25. Okay, and so that's our momentum, and of course remember to put your units, so it's kg meters per second, and that's our complete answer. And so we can essentially finish off that question. Okay, let's move to the second question, and but wait, we forgot something. I notice how I just gave my answer in 20 kg meters, 20 times. I gave my answer in this, right? And while this is correct, notice how this isn't in standard form. Now, yes, you know, teachers will be on your side. They will try not to remove marks wherever possible, but realistically speaking, you want to be vigilant, you want to be, on top of things. So you want to make sure you give your answer in, and this is supposed to be a minus as well, that's also making things worse. So you want to make sure that you're giving your answer in standard form, right? You don't want to make a silly mistake like that, which loses you a mark, which, to be fair, I just made that mistake, but just try and avoid it. And, make sure don't not to forget silly things like not putting the negative sign. That's just gonna bite you back. So let's move on to the second question now. Okay, so a bicycle has a momentum of 24 kg meters per second right here. What would the momentum of the bicycle be if it had twice the mass and was moving at the same speed and blah 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 blah? So this one should hopefully be fairly quick because we already know P equals mv, and so based on that we can just intuitively, tell we don't need to do any calculations. So twice the mass and same speed. Okay, so P equals 2mv, and so if you just look at these two, the difference is that you just have added a 2, so that's just going to equal 24 times 2 because you've just doubled the mass, right? And so you're going to get 48 kg meters per second, right? Simple. Let's look at B. Same mass and twice the speed, so we do exactly the same thing here, because we just, instead of doubling the mass, we double the velocity, so it's literally the exact same thing. So I'm just gonna make an arrow, and so that's pretty simple as well. And then we have 1/2 the mass and was moving with twice the speed. That's also pretty interesting, but essentially what we've done here now is we've taken one quantity, we've divided that by 2, and we've times that by 2v, right? And if we look at this, well, this is literally just like saying, okay, m2v over 2, right? Because it's like half of m. But when we have that, we can literally just cancel these two out, and what we essentially get is 24 kg meters per second. So that's also fairly straightforward. The same mass was moving with 1/2 the speed, and so there what we've basically done is we've just taken this and we've pasted that, and we've just removed, we've just removed this 2. That's all. So, and we just have mv over 2 now, the same mass and half the speed. So we just get, 24 over 2 equals 12 kg meters per second. Okay, now try this one. According to, let's try this one. According to the Guinness Book of World Records, the fastest recorded baseball pitch was delivered by Nolan Ryan in 1974. The pitch was clocked at 100.9 miles per hour, 45 meters per second. Determine the impulse required to give a 0.145 kilogram baseball such a momentum. Okay, now we already know that the impulse is equal to change in mv. I don't have exactly a delta sign, so I'm just writing change. And so we know now the pitch was clocked at 45 meters per second. So our final velocity which is v, is going to be 45 meters per second. And our initial velocity is just 0, because the ball isn't moving. Right, when he throws the ball, it's not moving. Determine the impulse required if it weighs 0.145 kilograms. So our mass, our m equals 0.145. Okay? And so essentially, what we have here is a case where we just increase the velocity, and that is just our change in momentum, right? Our change in momentum is 0.5 times 45 meters per second. And so we can just write it out as this. Change in momentum is nothing but 0.145 times the change in velocity, right? which we'll just write it as dv, right? D for delta. And so we get 0.145 times v minus u, which is just delta velocity, right? I'm just writing it out because it really helps when you're dealing with bigger numbers. So just make sure you write that every time. So then we have 0.145 times, well, 45 minus 0, so I'm just going to write 45. And that gives us, so we have 45 times 0.145, 6.525 Newton seconds. 6.525, and I'm going to say, the reason I say Newton seconds is because, like we said earlier, impulse is equal to F times t, right? So F times t. What's the unit for force? It's just newtons, and the unit for time is obviously just seconds, so we write it as Newton seconds. And we are right, 6.52 Newton seconds. You can also write 6.52 kg meter seconds, because that's just momentum again, but you know, either way is perfectly fine. Just depends whatever is easier for you. Let's try a slightly complicated problem, because now we have to calculate momentum, impulse, and the force. So this one kind of has it all included, right? It's kind of all in one. So this one's going to be a bit more challenging, okay? So let's do this one step at a time. So Kara Les was applying her makeup when she drove into South's busy parking lot. Pathetic, Kara. Unaware that blah blah blah, stopped in her lane 30 feet ahead. Okay, so we should probably write that down. And so our D equals 30 feet. And yeah, apologies for imperial measurements. I didn't make these questions. She rear-ended Lisa's rented Taurus, and her 1,300 kilogram car was moving at 11 meters per second and stopped in 0.14 seconds. Okay, so it seems by this question that we might actually not need the distance, because we already know the change in velocity and we know the time. So I'm just going to remove this 30 feet because it's just going to be more confusing with these terrible units. So let's look at let's determine the change in momentum, okay? So I like the first question, P, change in momentum equals M delta V, and so that equals that equals 1,300 times, what is it, 11, because we went from 11 to 0, so it's 11 minus 0. And so we stick that in our calculator, and we get, should be 14,300, but let me just do that real quick. Oh yeah, 143,000. Okay, simple, 143,000. And let's just write Newton seconds because it's nice and quick to write. Determine the impulse experienced by Kara's car. Exact same thing, right? Momentum change equals impulse experienced. So that's just 143,000 Newton seconds. Exact same thing, right? And now let's determine the magnitude of the force, okay? And we already defined the force being the change in momentum over time, right? And so if we take this, well, we have that here, F equals the change in momentum, which is 143,000 divided by 0.14. And so if we plug that in, we should get 143,000 divided by 0.14, a pretty big answer. It's roughly 1 million newtons. That's quite a bit. And so we can actually write this as 1 meganewton. Because, well, 1,000 newtons is a kilonewton, and you multiply that by 1,000, you get a million, so that's meganewton. So that should be roughly our answer. And actually, I'm going to put it to more significant figures here. I'm going to put 1,021,000 newtons. So we'll get 1.021 meganewtons. Let's see our answer. So please remember to make sure that you remember that momentum is in fact a vector quantity, right? And so we have to remember whether the answer is going to be positive or negative, because it can be both directions. So we have to remember that over here, Kara is decelerating, which means she's going starting to go towards the opposite direction. So we do need to make sure that we put a negative sign to indicate that, right? Because even though you could say that momentum change is an absolute quantity, we do still want to put that negative sign just to be sure, right? So we put negative 143,000 newton seconds, and then here we have 1 times 10 to the power 5 newtons, or 1 meganewton. And let's see the answer if we're right, and we are. So that is definitely a success. Anyway, that will about wrap it up for this video. Hopefully you found these questions helpful. If you have any doubt or question, please leave it in the comment below. We are more than happy to answer. Do like or subscribe if you do want to watch more of these videos and support our channel. And of course, visit this website, Physics Classroom, if you want to do the same questions that we were doing. This is it's completely unrelated. I just thought that these questions are good, so you might want to use this source if that's helpful to you. Anyway, that's all. Thank you for watching.